All right. Welcome, folks. On YouTube, we're going to do an exercise together. So let A and B be two arbitrary elements in our group, capital group G. Okay. We're going to prove that the inverse of A times B is equal to B inverse times A inverse. Okay. So recall, okay, in a group G, the inverse of some element G is an element G inverse satisfying G times G inverse is equal to the identity. And if I multiply them in the opposite order, I still get the identity. Right. I think it's helpful to write down the definitions as you're doing the homework. You don't necessarily want to or need to include the definition in your answer. I think it's better to box a definition and then just give your answer than to try to interweave the definition you're using with your answer. So in our answer, we're just going to use that definition. You don't need to give me the definition on your homework. You can write it on your homework, but write it in a self-contained way is my advice. And then just give your answer, pretending that you and I and everybody have already memorized and totally made our own this definition, even though you're still just learning it. Okay, so how are we going to prove that the inverse of A times B is something? We're going to take A times B and multiply it by the alleged inverse. Hopefully we get the identity. And also we're going to take A times B, multiply it by the alleged inverse in the opposite order, and hopefully we get the identity. Okay. So we're going to take A times B and then multiply it by the alleged inverse. Okay, we're going to massage things and hopefully we get the identity. And we're going to take A times B, multiply it by the alleged inverse in the opposite order, massage things, and hopefully get the identity. Once we've done that, we've proven what the inverse of AB is, because we found this element that when multiplied by AB in either order gave us the identity. So at this point, we can just say, hence, the inverse of AB is the inverse A inverse. Or in other words, i.e., the inverse of AB is the inverse A inverse. Okay. Framing these proofs is more important than the algebra that you do, okay? So a typical situation is that students will do this algebra, but they don't frame their answer correctly. The framing is more important than the algebra. And here I've done the framing. We're not really doing exams in this class, but if we were, this already would be 7 out of 10 points on the exam. And in some sense, you haven't done any math yet, but I would allege that the framing is more than math than the symbol manipulation. Okay, so in my last 2 minutes, let's check this. Associativity allows me to eventually group the parentheses here. And then B times B inverse is just the identity. And then the identity times anything doesn't change it. So this just becomes A times A inverse. I'm not showing all of my steps. You could show more if you wanted to, but I'm showing enough that I would be happy with. And then finally, A times I inverse is the identity. And we can do this again. We can use associativity to group the A inverse times A together. I've just changed the groupings, not the order of any of the terms. And then A inverse times A is the identity. And then the identity times anything doesn't change it. So this is just the inverse times B. And the inverse times B, well, they're inverses. So when you multiply them, you get the identity. That is our proof that in a group, the inverse of A times B is B inverse A inverse. And I've described this as the sock shoes property. If you put on your socks and then put on your shoes, how do you undo that? You then take off your shoes and then take off your socks. The order really matters. If you put on your socks and then put on your shoes, to undo that, take off your shoes first and then your socks. Don't try to take off your socks before you take off your shoes. Public questions. Thanks so much.